E aí galera, beleza? Esse vídeo vai ser um pouco diferente, pessoal, porque é o seguinte, vai ser uma apresentação, na verdade, no congresso ACM Symposium on Applied Computing, porque esse simpósio foi cancelado devido ao coronavírus, né, na sua versão presencial. Então, os apresentadores dos artigos, né, que eu tive um artigo aceito nesse congresso, eles têm que gravar vídeos das suas apresentações dos seus trabalhos. Então, esse vídeo vai ser a apresentação de um trabalho acadêmico, tá, na área de engenharia de software para o ACM SAC. O trabalho é o seguinte, pessoal, a gente estudou empiricamente, tá, o impacto de práticas de engenharia de software sólidas, como teste de unidade, documentação e integração contínua, em dois elementos muito importantes do código-fonte, que são os identificadores, que são os nomes que vocês dão para as variáveis, para os métodos, para as classes, e os comentários de código. Né? Quer dizer, será que essas práticas afetam a maneira com que os desenvolvedores nomeiam as coisas e também fazem comentário no código? Então, esse é provavelmente o maior trabalho nessa área em termos de tamanho, né? Que a gente analisou 6 milhões de identificadores e 6 milhões de comentários. Tá? E aqui nós vamos apresentar então os resultados desse trabalho empírico, que é também uma colaboração com a professora Claire Leguez, da Carnegie Mellon University, que é uma das melhores escolas de computação do mundo. Então fique ligado, assista o vídeo, é muito legal, tá? E é um trabalho acadêmico de engenharia de software, só que vai ser em inglês, então liga aí o closed caption para você acompanhar bem o vídeo. Esse é o segundo artigo que eu tenho aceito numa conferência SAC, Symposium on Applied Computing. A primeira foi no Havaí, em 2009. E se você está curioso, né? Eu surfei sim no Havaí. Foi a única vez na minha vida que eu surfei, foi lá no Havaí, quando eu fui lá para o SAC 2009. Então essa é agora a publicação do SAC 2020, né, a trilha de mineração de repositórios de software. Então assistam o vídeo, vale a pena para entender melhor como que é um trabalho acadêmico na área de engenharia de software.
Hello everyone, my name is Otávio Lemos and I'm an associate professor with the Federal University of São Paulo, and this is a joint work between me, my students, my PhD students Marcelo and Adriano, and Professor Claire Leguez from Carnegie Mellon University. Okay, so this is our SAC presentation, and here's my promise. After this presentation, you will learn how solid software engineering practices like unit testing, code documentation, continuous integration can impact on two very important elements of source code, which are identifiers, the names that we give for methods, variables, fields, classes, and other things in code, and comments, that is, code comments. Okay, so here's the context. Why are we focusing on identifiers and comments? First, identifiers make up to almost 70% of source code, so they're very prevalent in source code, and we expect that if you use solid software engineering practices, this will impact on these identifiers. And what about comments? So after the code itself, comments are considered the main source of documentation for code maintainers, so they're also very important. And here we want to look at code where we know that software engineering practices were used, and code where we know that software engineering practices were not used. Right? And for that, we used a machine learning classifier that was developed by Munaya et al. And that classifier can identify a GitHub repository where software engineering practices were used or failed to be used. Okay? So these are our two main research questions. The first one are related to identifiers. So are identifiers significantly different in engineered versus non-engineered code? That is, code where software engineering practices were used and code where software engineering practices were not used. And if so, if there is a significant difference, what are these differences, right? And the second research question is related to comments. Are comments significantly impacted, or are they different in engineered versus non-engineered code? And if so, what are these differences? So this is our empirical study, and we analyzed around 6 million identifiers and 6 million comments to get an idea if these software engineering practices do or do not impact on these two very important elements of source code. Okay, so this is Munaya et al. Work. Okay, so in order to tell whether a GitHub repository is engineered or not, they use these different aspects of software engineering, like architecture, community, continuous integration, documentation, history, issues, license, and unit testing. So what they do is that they look for evidence for good architecture practices, for good continuous integration activities, and so on. And with that, with those features, they built a classifier that can tell, when you give it a GitHub repository, whether or not this repository is engineered, that is, if it has used those software engineering practices, or if it is not engineered, that is, if it has not used those software engineering practices. And the classifier is fairly good at identifying these repositories. It has an accuracy of more than 80%. So more than 80% of the time, it can tell if this repository is engineered or non-engineered. Okay, so here for the identifier analysis, these are the numbers that we got. Okay, so we got many GitHub repositories which were classified as non-engineered, and many GitHub repositories which were classified as engineered. And then we extracted the code from both the groups, and we extracted the identifiers and comments from this source code. Okay, and we reached around 3 million identifiers among class names, interface names, field names, method names, and variable names for engineered and non-engineered code. Okay, so this is our subject, identifiers, for our analysis. And these are the features that we analyzed for identifiers. First, we looked at the length in terms of number of characters, right? So do these software engineering practices impact on the length of the identifier? The second characteristic that we looked was the format. Okay, so we looked into these different formats which are used very often, and they are used in Java conventions for like class names, field names, method names, and etc. Okay, so here you can see that we looked at lead underscore format, upper underscore format. You can see here examples of these formats: lower underscore, lower camel case format, upper camel case format, which is camel case starting with an uppercase letter, all lower, which is an identifier that only has all lowercase letters, and all upper. We also looked into the number of words and whether these words were English words or non-English words. These are the features that we looked for identifiers. Okay, for the comment analysis, we looked into around 3 million comments as well, right? From engineered code and from non-engineered code. And for this part of the work, we also used a classifier that was developed by Pascarella and Bacchelli. So basically, what this classifier does is, given a code comment, it can classify the type of the comment using using the classes, the types of comments that they have identified in code comments. Okay, so purpose would be comments that are telling what's the purpose of the code. What is that code used for? Notice are comments that warn the developers for something. under development are like commented code, for instance, is comments that tell that this part of the code is under development. And we also have style and IDE types of comments, metadata, and comments that do not fall in either of these categories are classified as discarded. All right. Okay, so let's go for the results. These tables are not very easy to read, so I'm just gonna go over some figures so that you understand the main results that we reached. So here we can see, for instance, that we have a significant difference in the length of the identifier, around 10%. So the engineered identifiers tend to be 10% larger than the non-engineered identifiers. And they also tend to have 10% more words than the non-engineered identifiers. And most of the words, like 77% of the words in engineered identifiers are English words. And this was a little less in non-engineered code. And all these differences were found to be significant with the statistical test that we ran to check if these differences were significant. So we can see that the software engineering practices do impact on identifiers. For instance, we can see that the length is impacted, the number of words, and also the percentage of English words that are used in identifiers. Alright, so here is for the formats that were used for identifiers. The main result here that you have to keep in mind is that non-engineered code tend to not follow the common Java conventions for these formats. For instance, class names are usually written with an upper camel format, and we can see that this is less often in non-engineered code, right? We can also see that for variable names, for instance, we can see that there are much more variable names in non-engineered code that follow different conventions than the well-established Java conventions. We also looked at the most common class names and most common method names used in engineered and non-engineered code. We also saw a difference there. We could see that engineered and non-engineered code had different frequent names for the classes and for the methods. A very surprising result that we got is that these sample names that are used for class names, for instance, foo, they are relatively more frequent in engineered code, which was kind of non-intuitive, right? You would expect that to appear more in non-engineered code, all right? We also looked at the frequent class words and method words. That is, there are words that are frequent in class identifiers and in method identifiers. So we can see, for instance, that class names in engineered code tend to have the test word more frequently. This is quite expected because engineered code would have more tests, right? So you would have more classes with the test word in their names, okay? So I'm not going to talk about all the differences and things that we and results that we got here. So you can look at the paper to see other interesting results that we reached. Okay, so these are for identifiers. Now for comments, the main result here, one of the main results here, was that the non-engineered code contains larger comments, which was kind of surprising because you would expect engineered code to have lengthier comments, and that was not the case. Okay. And here are the comments by type, right? By using the comment classifier. We can see here that the more sophisticated comments like under development, notice, style, and IDE were more prevalent in engineered code. Okay, so that's it. So for conclusions, we can see that software engineering practices like unit testing, continuous integration, they do impact on identifiers and comments. We found very significant differences between identifiers in engineered code and non-engineered code, right? For instance, identifiers are longer in engineered code and comments are longer in non-engineered code, okay? We also found that identifiers with formats not conformant with Java conventions were much more common in non-engineered code. And sophisticated comments, like comments that warn the developers, for instance, for some things that they should be careful in code, are much more common in engineered code. Okay? So that's it. If you have any questions, please contact me via email. You can ask questions and I will be happy to answer them. And we will also make available all the data that we used for this study. You will be able to download it and to replicate our study or to do other studies. After all, we have 6 million identifiers, right? About half engineered and about half non-engineered. So we found interesting patterns in engineered and non-engineered identifiers and engineered and non-engineered comments. You'll be able to have access to these data. We'll put them on a GitHub repository. The address is in the paper, so you can take a look at that. And please feel free to contact me. And that's it.